All right, everybody, another quick video here. This is going to tackle two things. One, it's going to explain how you compute IQR, and then also what it means, and then what the idea with outliers is related to all of this stuff. So real quick, this is another distribution. This is if I removed one player. I actually removed Matt Ryan from the other one. He was the 450-yarder. So he was way out here, kind of like an outlier, right? Something that's not typical. That was not typical. It was the only occurrence. I mean, we said that in the last video that this was pretty typical, about 150 to 300, maybe 320, was pretty typical for these quarterbacks. So with that being said, let's dive into what the IQR is. So for this data set here, the IQR is computed as Q3 minus Q1. So this would be 272.5 minus 190. That is 82.5. That's in yards, because that is what we are measuring our distance in yards. Okay. So the question I had was, what's the purpose of that? Well, what that does is, so let's see, 272 is somewhere in here, 0.5, 272.5, 190 is like somewhere in here. So this is like 190, 272.5. Okay, what is that saying? So what this does is it actually tells you where the middle 50% of the quarterbacks fell and like the range of that middle. It tells you like what's typical. Okay, what's typical. So what this means is that the middle 50% of quarterbacks during week 1 had passing yards within 82.5 yards of each other. Okay, so in other words, they were only half of them, 50%. So this is the interpretation when I just wrote. This is how you interpret IQR, just for more understanding. 50% of QBs had yards from 190 to 272.5. That's what the interpretation is saying. This is the interpretation of IQR right there, that sentence I just wrote. So it's also a measure of spread. It measures the dispersion. So the smaller the IQR gets, the more compact your middle 50% is. And that tells you that's tight. And then if it's a bigger IQR, then it tells you it's more spread out in the middle, that there's more variability. So IQR also measures the variation in your data, just like standard deviation did, okay? And so here's what we need to look at is what's the idea? So mean and standard deviation are paired together because you use the mean to compute standard deviation. And the median is typically paired with the IQR because the median sits halfway between the first and third quartile, okay? So other question I had was, how do outliers, like what's the idea with this thing called like outlier resistance? And I think this is a good example to explain this. So I told you I removed Matt Ryan. Matt Ryan was 450, okay? So in our data set, all right, I removed Matt Ryan and he was 450 yards, okay? So here's the data we have without Matt Ryan. If I go back to the other data set that includes Matt Ryan, so here's Matt Ryan out here. He's now included in our data with 450 yards. The mean and standard deviation, the mean was 236, the standard deviation was 87.338. So with Matt Ryan, the mean X bar was 236, and the other one, standard deviation was about 236, and the standard deviation was about 87. Well, look at what happened. If you think about the mean, what does that do? That takes the total of all of these players and adds them up and then divides it by however many there are, right? Well, this mean, by taking out Matt Ryan, the mean went down. The mean went down to 229. The standard deviation went from 87 to 78, which makes sense because Matt Ryan in this picture over here contributes a lot of distance to the standard deviation calculation. But that contribution is gone now. when you're thinking about adding or taking out somebody who's well above the average. So this has, this standard deviation here is less because we don't include Matt Ryan, who contributes a lot of distance and variation to our players. So in this case, standard deviation, they both went down. The mean and standard deviation decreased when I took out Matt Ryan, because Matt Ryan is such a high value, increases the average and then also increases the variation because it's so far from the average. So that the mean and standard deviation, they are not resistant to outliers. Like if we include outliers, then they change a lot because they're based on every single data point that we have. So the mean and standard deviation, we say, are not resistant to outliers. Like they change. So we would say not resistant to outliers. The mean and standard deviation, they change a ton when you have outliers. Now let's look at the median and quartiles, okay? Median and interquartile range. The median was 239 without Matt Ryan. And the median was 240.5 with Matt Ryan. So look at that. There's barely any difference between the median with and without Matt Ryan. Pretty much nothing. Like it's just literally a shift over by 1.5 yards. So the median didn't change very much. The IQR with Matt Ryan was 82.5. The IQR over here, what's that? That was Q3, I didn't do it yet, minus Q1, that's the IQR. So this has Matt Ryan in it. 275 minus 91, 191. That is 84. Okay, so when it reduced a little bit, which makes sense. 82.5 is a little less than 84, but it didn't change as much. So these two, the IQR and the median, resist outliers more than the mean and the standard deviation. So whenever we have skewness or outliers, the median and the IQR will always be preferred as typical, median being the typical measure of like what is a typical quarterback in this case. And the range, the interquartile range, sorry, is always preferred as standard deviation because it doesn't take into account those big outliers. It's only about the middle 50%. So when we describe the center and the variation with outliers, we should talk about the median and the IQR, not the mean and standard deviation, because the outliers influence them too much to make them not actually tell the true story, okay? And then one quick final little example here, just so you understand this a little bit better. Here's a data set, 1, 2, 3, 4, 5, 1, 2, 3, 4, 25. Okay, I don't think it's gonna take many people to tell me that, I don't think it's gonna take too much thought to tell me that the median for each of these data sets is 3. So that's the same. But the average for this data set is really gonna be way higher than this one, right? Because 25 is a huge outlier. So in this case, they have the same median, but the mean here is pulled, the mean gets pulled towards 25 because this is such a heavy weight to this distribution. Whereas here, the mean and median are both 3. So you have 5 data points. This outlier really pulls the mean, and the standard deviation over here is going to be really high. Even though they share 4 of the same data points, the standard deviation is going to tell you that this distribution's got a really, really big variation to it. It's true to some degree, but 1, 2, 3, and 4 are clustered together, and it's just 25 that's making it that big. They have the same IQR. The quartile 3 or 1 and 3 are to both 2 and 4, so it's only a difference of 2. So I'm just saying that the median, these 4 numbers here, tell you everything about Q1, Q3, and the median, and they're almost the same. These data sets are identical other than for these 2, but this mean and standard deviation would be so high for this that it doesn't actually tell you that these 2 data sets would even have anything in common, okay? So I'm kind of hoping that helps. Let me know if it does.